Okay, so in this video I'm going to have a look at the 2016 Leaving Certificate Higher Level Paper 2 question 9. So this is it here. It talks about data on earnings which were published for a particular county, and the data shows the annual income of people in full-time employment which was normally distributed with a mean of 39,400 euros. So I've written that down here. This is the population mean here, and a standard deviation for the population of 12,920 euros, so I've written that here as well. Now the government intends to impose a new tax on incomes over 60,000 euros. Find a percentage of full-time workers who will be liable for this tax. So in other words, what we're looking for is we're looking for the percentage of people who earn more than 60,000 euros. So this is our x value here. Our x value, what we're looking for initially is the probability that people will earn more than 60,000 euros, and we can convert that then to a percentage. So our what we're looking for is the probability that our x value here will be greater than 60,000 euros. So we've got to convert this 60,000 euros to a z value first, so we use this standard formula here. Z is equal to x minus mu over sigma. So we put that into we put this in here, so we've got the probability that z will be greater than 60,000 minus 39,400, which is our mu here, divided by our population standard deviation, which is 12,920. So we convert that to a z value, and what we actually get is what we're looking for here is the probability that z will be greater than 1.59 standard deviations above the mean. So remember what we're looking for. We're looking for people who earn more than 60,000 euros. So we're looking for the probability of someone, our x value here, in other words, earning greater than 60,000 euros. We have to convert that to a z value to look up that probability. So we end up with a z value of 1.59. So what we're looking for is the probability of someone earning money that's greater than 1.59 standard deviations above the mean, and I've drawn it here. This is our standard normal distribution here with a mean here of 0 and 1.59 standard deviations I've marked here roughly on our diagram. So we're looking for this area of the graph up here. Now you can look up positive values in your tables, and we have a positive value here. It's plus 1.59, so that's fine. But when you look it up, it gives you the probability of appearing down here, so in other words less than 1.59. So what we've got to do is do 1 minus the probability that z is less than 1.59 to give us this area up here, because remember the area under the probability of appearing under this curve in total is going to be 1. So we've got to do 1 minus the probability of appearing down here to find the probability of appearing up here. So when we do this anyway, we get 1 minus this probability here. Now if we look that up, we want 1.59 on our table. So if you look at this here, we've got, this is the table here, so this is our 1.5. we go out to 9 here, this is 9 here, so that's 0.9441. 0.9441. And when you work that out, then you get 0.0559. So that's going to be equal to 5.59%. Okay, just get rid of this thing. Okay, there you go. Now this is 5.59%. So there's a 5.95% chance of appearing in this part, of earning more than 1.59 standard deviations above the mean. So just to go back to the question again, it says to give the answer correct to 1 decimal place. So it's always important to go back and, once you have the answer written down, go back and read the question again just to make sure you have the answer written in the way that's actually required. So we need this to be written as 5.6%. And that's it. That's the probability. What way did they phrase it here? Find the percentage. It's the percentage of full-time workers who will be liable for this tax. 5.6% to 1 decimal place. Okay, so let's look at the next question then. It says that the government will also provide a subsidy for the lowest 10% of income earners. find the level of income that the government will stop paying the subsidy correct to the nearest euro. So in this particular case, if we look at our standard normal curve again, the government are going to look at people who earn, let's say somewhere down here, and this is going to be 10%. This is going to be your 10% down here somewhere, or 0.1 in terms of probability, if you like. 0.1 in terms of probability. So we've got to find, first of all, find whatever this z value down here is. We've got to find what that z value is. So 0 here. And then work backwards to find the actual salary that that represents this z value here. So how do we do that? Well, this 10% here, this 10% of people, that's 10% of people earn this amount of money down here, if you like, or in this part of the normal distribution. So that's 0.1 in terms of probability. So what we do is we look up our table here again, and we look for 0.1. These are probabilities in here, so we got to find 0.1 in here somewhere. Now, the nearest we can get to 0.1 is actually this figure here. It's 0.8997. 0.8997 of a probability. It's very close to 0.1 in terms of our actual percentage. And the reason for that is, remember, this is going to be a negative. This is going to be a negative z value down here. This is going to be minus something or other here. So really, what we can only look up positive values. So really, what we have to do is look at the other side, the image of this part of the graph here. So really, what we're going to do is look at this part up here. And you've got to remember here that this is going to be 10% of the population as well up here. But our table won't actually allow us to look up greater than values, if you like, only less than. So really what we're looking at is all of this part here in terms of the probability table. And that's going to be 90%, not 10%. So all of this here, if we look for 90% in our table here, which is what I'm doing here. Remember, this is actually our 90%. Where did I find it here? Here. This is 0.8997, which is roughly 90%. It's just below 90%. That will give me a z value of 1.28. That's about as near as I can get to 90%. 1.28. So in other words, what I'm saying here is this here is 1.28 here of a z value. That will give me 90% down here probability and 10% up here. And that 10% up here is going to be the same as this 10% down here, if you like. So in other words, the z value that I'm actually looking for down here is minus 1.28. Minus 1.28. Okay, so how does that help us? Well, we know the z value here, and we know that z is equal to our x minus mu over sigma. Now our z value is down here. It's minus 1.28. So we want minus 1.28 to be equal to some x value. Remember, this x value is going to be the salary that we're looking for at this end of the table here. So we don't know what that is. We know that mu is 39,400, and we know that sigma is 12,920. So you can see here we have our equation. We have our z value here at minus 1.28. We don't know what our salary is, our cutoff point for this levy, or this subsidy, I should say, that the government is going to pay these people. We do know the mu, we do know the standard deviation here for the population. So you just have to manipulate this, and what you end up with is x is equal to 22,862 euros. So this is the amount of money here. This is the level of income at which the government will stop paying this subsidy. So if you earn below this, you'll get this subsidy from the government. And that's it for part 2 of this question. Okay, so let's look at part 3 here. Sometime later, a research institute surveyed a sample of 1,000 full-time workers. So immediately we can write down here our sample size, our n is equal to 1,000. Randomly selected and found that the mean annual income sample was 38,280. So again we can write down here x bar, this is a mean of our sample, is 38,280 euros. Okay, test the hypothesis at a 5% level of significance that the mean annual income of full-time workers has changed since the national data was published. Now from the previous question, the national data was published, it said that mu was 39,400, that was our population mean previously, and it had a standard deviation of 12,920 euros. So this is what was being stated previously, and this is our sample of 1,000. Now we're getting 38,280 euros as a mean for our sample of 1,000. So we've got to test to see has anything changed. So they ask it here, so that the mean annual income of full-time workers has changed since the national data was published. So we've got to state the null hypothesis and the alternative hypothesis and give your conclusion in the context of the question. So it's important to state at the end whether you're accepting failing to reject, we should say, or rejecting the null hypothesis, and then make a statement in relation to this particular story itself. Okay, so let's start. Now there are a few ways of doing this. So first of all, anyway, we've got to state H0, the null hypothesis, and that is that mu, what was stated previously was that the mean was 39,400. So we state that again, 39,400. We want to see has that changed. So that's our null hypothesis. Our alternative hypothesis then is just simply that mu is now not 39,400 euros. So let's start the test then. Well, we're talking about a mean here, a sample and a mean, so we're going to use, we got to convert this x bar here, our mean here, to a z value. And remember, our z value for means of samples is our x bar minus the population mean over sigma over root n. So if we just substitute our values in here, so our x bar is 38,280, we subtract the population mean here, which is 39,400, and then we divide all that by our sigma, which is 12,920, and we're going to divide that by the square root of 1,000. Okay, so that's a fairly simple calculation. You can do that yourselves on a calculator, and what you'll end up with is minus 2.74. So this is our z value. This is our z value for this particular sample mean. So again, if you look at our standard normal distribution here, we've got our our mean here. Our cutoff point, or our critical levels here, are 1.96 and minus 1.96. So this tells us where our critical region is. So our critical regions are here and here. Now in our particular question, we've got a z value of minus 2.74, and we can see minus 2.74. Minus 2.74 is right in here in our critical region. So in this particular case, we've got to reject the null hypothesis, because minus 2.74 is in our critical region. It's less than minus 1.96. So minus 2.74 z value is less than 1.96. Therefore, the result is significant. The result is significant. So therefore, we reject the null hypothesis. So you don't only just state that, you've got to state it in the context of the actual question itself, and we would say the mean income has changed. So remember, this is what's being stated initially. This is what was stated previously, that the mean income was 39,400 euros. We took a sample of 1,000 and found that the mean was 38,280, and we want to now check to see, is that a significant result? It doesn't look like it's too far away from it, but when you actually do the maths, when you do find the z value, you find that it is in the z value is in the critical region. It is a significant result, so we reject the null hypothesis. Now there are other ways of doing this. I'll just run through those quickly here. What you can do, in fact, and I'm probably going to run out of room here, just actually move this out of the way. This is the next part of the question, so let's see if I can just move that down a little bit. Just to give myself some room here. Okay, so what you can do here is set up confidence intervals. So normally what you can do here is say that the population mean is going to be somewhere between your sample mean and plus or minus a margin of error. So what you do is you work out a margin of error and you add and subtract it to your sample mean. So when you do this, I mean, it's our sample mean here was 39,000. What was our sample mean here? Was 38,280. 38,280. So you can say 38,280 minus a margin of error. Now our margin of error is going to be 1.96 times this 12,920. So this is sigma over root n. Margin of error is sigma over root n, remember. So that's 12,920. Let me just get rid of this for a second. So it's 12,900 over square root of 1,000. So that's going to be less than or equal to mu. And then you add it as well. So it's x bar plus our margin of error, which is 1.96 sigma over root n, which is 12920 over square root 1,000. So when you work this out, you get a confidence interval of 37479, 3747. I just .2 on this side, and you get 39080.8 on this side. Now, so this was our sample mean here and here, so we got to put in less than or equal to here as well. So we end up with a margin, our confidence interval at 37,479.2 euros on the left hand side and 39,080.8 euros on the right hand side. So our population mean should end up somewhere between this to accept or to fail to reject our null hypothesis. And we can see that 39,400, this was our stated population mean, is actually outside this confidence interval here. It's outside this confidence interval here. So again, we reject the null hypothesis and the mean income has changed, in other words. Okay, so that's another way of doing it, by setting up confidence intervals and seeing does the what's being stated or what has been done previously or has been accepted, what is the status quo, is it within or outside your confidence intervals. Okay, so let's just have a look at the next part here now. Again, I'm going to run out of a little bit of room here. Let me just move this down. Give myself a little bit of room here. Okay, that should be okay, I think. Now, The next part then talks about the Research Institute surveying 400 full-time farmers randomly selected from the full-time farmers in the country, and found that the mean income of the sample was €26,974 and the standard deviation was €5,120. Assuming that the annual farm income is normally distributed in the country, create a 95% confidence interval for the mean income of full-time farmers. So again, we do something similar to what we did earlier in the previous question. We just want to set up a confidence interval. So again, so we set up mu here is less than, greater than, less than. So what we want to do here is do our x bar again minus our margin of error, and our x bar here plus our margin of error. So it's similar to what we did in the previous question. So our mu here again is going to be less than or equal to. So they're saying that when they took the sample, they found that the mean income for the sample was 26,974. So that's our x bar here. So 26974. I'm going to subtract the margin of error here. Same on this side, so it's going to be 26,974 on this side. I'm going to add the margin of error on this side. So again, it's going to be 1.96 times. Because we're talking about means here, it's going to be sigma over root n again. Our sigma here is our standard deviation, which is 5120. 5120. And that's going to be over the square root of our sample. The sample in this case was 400. So we put 400 in here. Same on this side. So it's going to be 1.96 times sigma over root n, 5120 again over the square root of 400. Okay, so again, you just work that out. This is just calculator work at this stage. You can do it in a few steps. Don't try and type all of this into your calculator. Do it in a few steps. But you get a final value of, on this side, 26472.24. And on this side we get 27475.76. So this is our confidence interval at a 95% level, okay, for the mean income of full-time farmers. So the population mean should be somewhere between these two values here for farmers' incomes. Okay, so this part here now, part C just says that it is known that data on farm size are not normally distributed. The Research Institute could take many large random samples of farm sizes and create a sampling distribution of the means of all these samples. Give one reason why they might do this. Okay, so again, let me just move this. So the reason here is that the distribution of sample means will be normally distributed. This is really the central limit theorem. If the underlying population distribution is not normal or is normal, so long as your sample sizes are large enough, we usually take greater than 30, then your distribution of the sampling means will be normal. So in other words, our answer here really is the distribution of sample means will be normally distributed. This is because they're talking about many large random samples here. So as I say, once the it doesn't really matter what the population distribution looks like, so long as your sample size is large, greater than 30 is what we usually use, then the sampling distribution of the sample means will be normally distributed, with a mean of the population mean and the standard deviation of sigma over root n. That's your central limit theorem. Okay, so let's move on to this question here, which is question D. I think this is the last one. The Research Institute also carried out a survey into the use of agricultural land. N farmers were surveyed. If the margin of error of the survey was 4.5%, find the value of n. Now, without any further information here, we really have to use the fact that our margin of error here is just simply 1 over root n, which is an approximation for the other margin of error formula that we use, the sigma over root n formula, 1.96 sigma over root n, or population proportion margin of error, which is 1.96 square root p hat 1 minus p hat over n. So we're going to use this here anyway, because we don't have any more information than what's given in the question. So they're telling us that this is equal to 0.045. Our margin of error is 4.5%, which is 0.045. We've got to work out n here. So it's just simply manipulating this formula and isolating n here. So what we get here then is root n times 0.045 and then divide across. So you get 1 over square root of n is equal to 0.045. Square both sides, you get, sorry, I've made a mistake here, 1 second. Let me just go back here again. This is 1 over 0.045 here is equal to square root of n. There you go. Now square both sides. So you've got 1 over 0.045 here. Square this side and you get n on this side. So you get n is equal to 493.825. Now it says n farmers were surveyed, so you can't survey 0.825 of a farmer. So your answer here is really, in this case, I would think 493 here is fine. 493 farmers. Okay, and that's really it for this particular paper question.